Hello everyone, welcome back to White Collar. Today in this video, we are going to discuss about the mixtures in detail. Before getting into the video, subscribe the channel and share this with your friends. Without any further ado, let's get right into the video. What is a mixture? A mixture is the physical combination of two or more substances without any chemical reaction, in which there is no change in the basic characteristics of the substance. In simpler words, two or more substances are combined physically or manually. We can separate the two substances manually too. Now, mixtures are further getting divided into homogeneous and heterogeneous mixture. At first, let's see what a homogeneous mixture is. Homogeneous mixture is none other than the solution. Whenever you come across a word as homogeneous mixture, it should remind you that it's nothing but a solution. So, from here on, I'll address the homogeneous mixture as solution. But wait! For that, we need to know, what is a solution? As the name suggests, solution is a mixture of solute and solvent. To be simple, solute plus solvent is equal to solution. But, how can we differentiate between what is a solute and what is a solvent? The quantity scale comes for the rescue. The material with less quantity becomes solute, whereas material with more quantity becomes solvent. Let's see the characteristics of the solution. The solution basically has uniform composition, meaning the amount of substance is equally mixed in all parts of the mixture. Also, the ingredients of the solution cannot be separated by mechanical methods, such as filtration. We can further divide the solution into unsaturated, saturated and supersaturated solution. An unsaturated solution is a solution in which a solvent is capable of dissolving any more solute at a given temperature. A saturated solution can be defined as a solution in which a solvent is not capable of dissolving any more solute at a given temperature. A supersaturated solution comprises a large amount of solute at a temperature, wherein it will be reduced. As a result, the extra solute will crystallize quickly. Now a quick question to all of you. What do you think will happen if we increase or decrease the temperature of a saturated solution? Will the solution become supersaturated or unsaturated? To better understand this, we need to know a simple concept: the relation between temperature and solubility. The effect of temperature on the solution and how it responds. As we can see, solubility is directly proportional to temperature. The higher the temperature is, the better solubility the solution has, and the quicker the solvent dissolves the solute. Now, let's just say we are having an unsaturated solution. If we increase the temperature, some of the solvent gets heated up and might evaporate, but the solute stays there as usual. So, lesser solvent than the unsaturated solution, making it a saturated solution, where it can't dissolve any further solute. If we increase the temperature furthermore, more of the solvent will evaporate, and even more lesser amount will be the remaining solvent. In this case, it turns out to be a supersaturated solution, where the solute will crystallize eventually. It's the same story all over again if we decrease the temperature. If we decrease the temperature, the solvent will undergo condensation, become saturated from supersaturated, and if we decrease it furthermore, the saturated is going to become an unsaturated solution. Now, coming to the heterogeneous mixture. What is a heterogeneous mixture? A mixture of substances in which the substances appear to be different rather than identical. The heterogeneous mixture can be still divided into suspension and colloid. What is a suspension? What is a colloid? We are just going to see. In suspension, particles won't completely dissolve. We can visually see the particles settle down or not completely dissolved. In colloid, particles completely mixed with each other. In suspension, size of the particles is highest. In colloid, size of the particles will be higher than solution, but lower than suspension. A perfect example for suspension is sand mixed with water, and a great example for colloid is milk mixed with water. Up next, we are going to see, what if the different states of matter mixed with each other? Like all three basic states of matter just randomly get mixed with each other? For that, we need a dispersed phase and a dispersion medium. And we will also see what it's called and some few handful of examples for each and everything. solid plus liquid is called sol. Some of the examples include paints, fruits, jellies, gels and dyes. Liquid mixed with liquid is called emulsion. Some of the examples are milk, salad, cream and mayonnaise. Gas mixed with liquid is called foam. Examples include beer froth, soap suds, and whipped cream. Solid mixed with solid is called solid sol. Few of the examples are alloys, gemstones, ruby and glass. Liquid mixed with solid is called solid emulsion. Butter and cheese are some of the examples of the solid emulsion. Gas mixed with solid is called solid foam. Pumice, marshmallow and meringue are some of the examples of the solid foam. Solid mixed with gas is called solid aerosol. Some of the examples include smoke, dust in air and bacteria in air. Liquid mixed with gas is called liquid aerosol, and some known examples are fog, mist, cloud and sprays. With this, we've reached the end of this video. Hope y'all like it and don't forget to share this video. Subscribe the channel for more and please don't forget to click the bell icon for upcoming videos. We'll see you guys in the next one. Until then, stay tuned.